In the last video, we have seen different quantities, physical quantity for simple harmonic oscillator, displacement, amplitude, like this we have seen. Today in this video, we are going to see what the equation of simple harmonic motion. First, let's see what's the meaning of equal simple harmonic motion. Equal simple harmonic motion is an equation for displacement of simple harmonic oscillator. Okay, if we get the equation for simple harmonic oscillator, so that is the equation for simple harmonic motion. But a simple harmonic oscillator makes a simple periodic motion. It's a periodic motion. Any periodic function can be used to represent simple harmonic motion. In trigonometry, we have only two periodic functions, either sine function or a cosine function. That's why the displacement here I take x. Why x? In our example, I have taken a body moving horizontally. Horizontal direction or we take x direction. That's the displacement I take as x. X equal to a, either a sine omega t, or I can write x equal to b cos omega t. And since I am using two different periodic functions, I take different amplitude, one as a, other as a b. Or we can combine both the simple harmonic motion, make another simple harmonic motion. Okay, that means when two periodic functions combine together, it's going to be another periodic function. Okay, so that's why I combine that. Also, I can write equation of simple harmonic motion or equation of displacement. Okay, actually, this is a general, the last equation what we wrote here, that's a general equation for simple harmonic motion. These are the particular cases. So, but here in general equation, there are two periodic functions we get, sine function, cosine function. So, we want to bring it to only with one function, either sine or cosine. Okay, so that's why now we have to replace these constants, a and b we have to replace. That a I am writing d cos phi and b I am writing d sine phi. So already two constants, now we bring two more constants. So after we will see what's the meaning of this. But by this we are going to simplify the equation. When you substitute equation 1 and 2 in the above general equation, so you will get the above equation. In this d is common, take it outside. You will get d into sin omega t cos phi plus cos omega t sin phi. That's in the form sin a plus b. Sin a plus b equal to sin a cos b plus cos a sin b. So that's why this equation we can write x equal to d sin omega t plus phi. Okay, that way we simplify. Okay, now this is the equation for a simple harmonic motion. See here, I have taken a as a d cos phi and b as a d sin phi. If I take other way around, suppose this is sin phi, this is cos phi. Here I will get cos omega t plus phi. That's why if the final equation for displacement, we can put either into sine function, cosine function, depends on how we choose the constants. Okay, so that's why equation of simple harmonic motion, you can show either by sine function or cosine function, nothing wrong on this. Now here, sine of something, the something what is angle. Okay, and here d what it is a resultant amplitude. D is a resultant amplitude of simple harmonic oscillator, and this angle omega t plus phi we call phase of simple harmonic oscillator. Now we introduce new quantity, how to define, what's the use, those things you'll see later. Okay, phase of simple harmonic oscillator. Now at time t equals 0, you put t equals 0. What will happen? So this term becomes 0, only phi becomes a phase. So that's a phase initially what the SHO going to have. That's why we call initial phase. Phi is known as initial phase, also known as phase constant of simple harmonic oscillator. Okay, so now how to find this d in terms of a and b? Square and add both the equation. You'll get a square plus b square equal to d square into cos square phi plus sin square phi. So you know sin square theta plus cos square theta equal to 1. That's it, that's going to be 1. That's why d square equal to a plus a square plus b square, or d equal to square root of a square plus b square. So that's why when you combine two simple harmonic motions, so the resultant amplitude we can calculate like this. Okay? For example, we had two simple harmonic motion. One got amplitude equal to 3 centimeter, other one got amplitude equal to 4 centimeter. So when you combine, what the resultant amplitude? Square root of 3 square plus 4 square, that's equal to square root of 5 square. How much it is? 5 centimeter. So 5 centimeter get resultant amplitude. And the phase we can calculate. So equation 2 divided by 1, sin phi by cos phi. How much it is? Tan phi. Tan phi equal to b by a. So using this equation, we can also calculate the phase constant or initial phase of simple harmonic oscillator.